Today we're looking at more complex graphs and the key features that we can identify from those. We're still using all of the terms we used in our last lesson and previous lessons before that. Domain, range, y-intercepts, relative and absolute minimums and maximums. Okay, these are mainly the key features that we're going to be looking at. It's just that the graphs we look at today are going to be a little bit more complex, so they won't have endpoints and things like that. We'll see as we continue. So let's look at this graph of the function f of x equals 1 over x minus 2 squared, where the whole thing is squared, x minus 2. And then it's graphed below for us. And we can see it here. But what do we notice, first of all, how this is different from the graphs that we've been looking at? Well, right here we can see arrows that indicate that these graphs keep going in these directions. Positive y direction continues in the negative, and then the positive x directions, they both continue. Okay, they don't have endpoints like the graph on the previous lessons. These actually just continue on basically forever into infinity or negative infinity. So that would be how I would describe these as different from the previous ones. They don't have endpoints. They continue on. Okay, so let's say that they gave us that, and we need to give them the domain and range for this function. And then we need to find the y-intercept, the absolute maximum, and the absolute minimum. All right, so, domain is our inputs, our x value, our independent variable. All of these are the same kind of words, like synonyms for basically the same information. We can see that in our x's, it's going on forever, okay, into infinity. It's going on forever into negative infinity. The only kind of problem we see is that for some reason it's not here. It's not ever going to cover 2, okay? So our domain is not going to include 2, but every other number from negative infinity to infinity is going to be included. And so we can say that, and basically we'd say that with our words. The domain is all of the real values of x except for when x is not equal to 2. X cannot be equal to 2. I think I put a double negative in it. All real values of x except for x equals 2. Why 2? Well, if I put 2 into this problem, 2 minus 2 is 0. 0 squared is 0. 1 divided by 0, that's a problem. You cannot divide by 0 ever. Okay, math does not support it. It even tells you it over here. Okay, if you ever division by 0 is undefined. Okay, and so that's why it's trying its best to never ever touch 2. It can touch every other number. 2.008, fine. 1.999999999, fine. But 2, absolutely no. That would make this a dividing by 0 problem, and that's why you'll see this little space and gap right there. Okay? And so the domain is everything, all real numbers, except for 2. You cannot equal 2. Okay, our range goes up forever into infinity, so all the positive numbers basically. Okay, and then it comes down. It never actually goes into the negative territory. It tries its best to get closer and closer until infinity. Goes 1, 0.5, 0.4, 0.3, 0.2, 0.1, 0.0000001. Oh, it never will touch 0. So our range is going to be all the numbers greater than 0. And that's what we put, range y greater than 0. all real values of y greater than 0. Why is it greater than 0? Why can we not have negative answers? Well, it turns out that since this is squared, even if I put negative 50 or negative 1,000 minus 2, whatever that number is times itself would make it positive again. And so I'd have 1 over, let's say, 1,000,000,000 or whatever. It doesn't matter. It would never become a negative as a whole, so I'd never get into the negatives. Okay? The fractions, the denominator would continue to get larger and larger, which means that 1 divided by that would be closer and closer to 0, but it would never actually get to 0 either. So we're going to write our range as everything is greater than 0, since we can't have the negatives, and it's never getting to 0 because the fraction 1 divided by bigger and bigger and bigger numbers is just getting closer to 0, but without ever actually getting there. There is nothing that you can say 1 divided by something is 0, because we can't divide by 0. So all real values of y is greater than 0. Okay, the y-intercept. Well, remember, y-intercept is when x is equal to 0. And so if I put x is equal to 0, I'll get negative 2. Negative 2 squared is 4. 1 over 4 would be my y-intercept. 1 over 4 is 0.25. Okay, my y-intercept is 1 over 4 or 0.25. 0, 0.25. When x is 0, y will be 0.25. And that is the definition of y-intercept when x is 0. That's where it touches the line, like we learned last time. Okay, absolute maximum. Okay, it never stops getting higher and higher, so there's no maximum. It's infinity. And minimum, it never stops getting lower and lower without ever touching 0, but it never stops getting closer and closer to 0. So there's no minimum, no absolute and minimum or maximum. And that's the kind of information we want to be able to look at a graph and tell. So let's keep going. Let's look at this one. The function 8 plus 2x minus x squared. Our domain is going to be, well, you see our arrow says that it's going to keep going down into the left forever, down into the left. So it's going to be covering all of the left numbers eventually. Well, into infinity. It never stops, so it has all the time in the world to do it. And so similarly on the right side, it's going down and to the right and forever. So our domain is going to be everything. There is no gaps, okay? There's no saying it can't be a number. It's just every x number. All real numbers are the domain for x. Okay? And just to show you that we can write that in several ways, I can say with words all real numbers and just say it's everything. I can put it in interval notation and say from negative infinity to infinity. I'm trying to find the infinity signs. There they are. So from negative infinity, I want to put that in parentheses, to infinity. Okay. Negative infinity to infinity, that would be my interval notation. Notes, parentheses means open, it never actually gets there. And I could do it into my inequality. I could say negative infinity is less than or equal to x, which is less than or equal to infinity. Oop, that didn't show. might have to, there it goes, save it. And so that's 3 different ways to write the same information. All real numbers means every number. Okay, that's negative infinity to infinity, every number. Negative infinity is to infinity. X is everything in between. Only one of these is like, you only need to write one of these, but all 3 of them are the right answer, basically. It's just different ways to write the same answer. Everything is the answer. The domain covers everything on the x-axis. The range, well, you can see that it goes down forever, so that's negative infinity up to 9. It stops at 9. And so our range, we're going to put, we could say y is less than, let me use the actual button, y is less than or equal to 9. Okay, as long as everything less than 9, including 9, that's one way to write it. That's our inequality notation. We could write it as from negative infinity to 9, but including 9, so we need to use the bracket like that to say inclusion and interval notation. Remember, parentheses is open circle, brackets is closed, and we're including 9. So that would be two different ways to write the same information. Either one of those is fine for right now. You just got to be able to recognize when they say it. And so from 9 on down to negative infinity, the range goes up to 9 and then stops. It doesn't go above it. Y-intercept, all right? We can see that it's 8, but let's make sure we know how they got that. Remember, the definition of y-intercept is when x is equal to 0. So I would replace the x's with 0. 2 times 0 is 0, minus 0 squared, which is 0. 8 minus 0 is 8. So our y-intercept is 8. Again, remember, several ways to write the same thing. We can put it in ordered pair, because that is the definition. When x is 0, y is 8. I think we're going to stick with writing it like this right now to make sure that you remember that it's a point on this graph. That's the point that the y-intercepts, 0, 8. Any relative or absolute minimums? Okay, there is no dip that I can see that has a low point. And these go on forever. There's no endpoints, so there is no absolute minimum, because you can always go lower, basically. So no absolute minimums, and any maximums, let me just put none. Maximums, there is a maximum. There is a absolute and relative maximum. It's the same one. 9. Okay, 9. That's as high as it goes. So again, we're just looking at graphs, and we're trying to determine, the key features of a graph, which we've already said: maximum and minimums, y-intercepts, domain and range. These are some of the key features that we can just look at a graph and tell. It's not much to calculate. We might need to make sure of something using our y-intercept and everything. We can just look at it and see, but to be exact, we want to use a calculation. But it's not like it's a hard calculation. You just set x to 0 and work it out. Okay, number 2, very similar. Domain, it goes on forever left, it goes on forever right. All real numbers from negative infinity to infinity, however you want to say it. Range, very similar. It goes down forever, it goes up forever from negative infinity to infinity. All real numbers, however you want to say it. The y-intercept, where does it cross the y-axis? I can just look at this and see. 0 is the definition of y-intercept. X is 0, then negative 1. 0, negative 1 would be my guess. But we can plug it in and work it out 2 times 0 is 0, minus 1 is negative 1. Yes, now y-intercept when x is 0 is negative 1. So ordered pair, 0, negative 1. That's the y-intercept. Relative absolute minimums. It never stops going down. So, and there's no like dip or mountain peak. It's a line. And so there are no absolute relative or minimums or maximums because it keeps going up forever. Explain whether this represents a function and how you determine this. Remember the other definition we had from our first lesson on section 6, vertical line test. I can draw a line at every point and it only crosses once vertically, and that is a definition of function. Since it has one input, it has exactly one output. Vertical line test tells me this is a function. Okay, here's another function, y equals 2 to the x power. Yeah, remember you can put x's anywhere. Okay, x's can be the exponent, x's can be the main number to be worked with, x's can be squared. Domain, negative infinity to positive infinity, goes on forever in both ways. Range, okay, it goes close to 0, but never actually reaches it. So, and it goes up to infinity. So from 0 to infinity, okay, it never reaches 0 though, so it'd be open. Or we can just say it's greater than 0. The range y is equal to greater than 0. What's the x-intercept? When x is 0, this function would be 1. Just because we can say that 2 to the 0 power is 1. Absolute or relative minimums or maximums, none. It goes up forever, it goes on forever, left to down. No absolute minimums or maximums. Okay, so that's like a brief overview of this lesson, reading graphs and saying the words that we've been talking about. If you had a graphing calculator at home, and you do have x plus 1, it's called Desmos.com. We can try some of these. The Desmos graphing calculator. The free tool. Okay. Negative 3x plus 4. And so you would put in here negative 3x plus 4. And it will graph it for you. And you can kind of zoom in and out or just move it around. You see that it's a line that's going down, decreasing. So we can graph these, and then we need to kind of say what's the domain and what's the range. Now they give you a list here that we can sort of like match these domains and match these ranges to this problems that we graph using the Desmos graphing calculator, or if you have a graphing calculator, you can use it. Okay, let's look at the first one. It goes left forever, it goes right forever, so all real numbers would be the domain, 1. I put a 1 right here. And in the range, it goes up forever, it goes down forever. All real numbers would be my range. 1a is how I would do this problem. 1a, like that. Let's skip down to y is equal to the absolute value of x plus 1. Let's try that one. Okay, let's go to the Desmos calculator. Desmos.com/calculator. We're just going to put ABS for absolute value, x plus 1. So make sure everything's closed off, and there we go. So right here, absolute value of x plus 1. So let's see, domain for this one. Well, it goes forever in the this direction, it goes forever in this direction, negative infinity to infinity, all real numbers. So that'll be a 1. And then the range is everything that's greater than or equal to 0. It starts at 0 and it goes up or this way and that way. And so we have all real numbers such that y is greater than or equal to 0. That's going to be D. Okay, so make sure you use this calculator if you need to graph functions. And we just need to make sure that we can tell the domain and the range for different functions. For like example 4 over x. Okay, 4 divided by x. And we see right here, we can zoom in and out, that the domain is negative infinity up to, and then it won't touch 0 because you can't divide by 0. I can already tell that 0 is not in the domain. It's not covered by this line, and it goes into positive. So everything except for 0, all the numbers except that it cannot be 0, 3. And the range, well, it goes all the way except you can't get 0, because since you can't divide by 0, there's no way to turn this 4 divided by something into 0. So that's another one that it cannot be. Y cannot be equal to 0, but it does go up forever in that direction. So all the numbers, as long as y is not equal to 0, B. And there you go. So you could try these other ones on your own using that Desmos calculator, or if you have a graphing calculator, you can use it. How can you determine from a function's graph whether it has any maximums or minimums? Well, maximums would be if it had like an endpoint or a hill, like it made a hill for kind of version, or like that. Vertex, maximum, and minimum would be if it had something that looked like that, or it had an endpoint. Okay, right there. Maximum endpoint would look like just the opposite, sort of, where it has a point right there. So maximum and minimums you can tell from the graph if it has stopping points along either at the top or the bottom. So you can just try like 8, 9, and 10 using this graph for the domain, range, y-intercept, maximum, and minimum. Okay, remember, if it's going to go on in certain directions and it's not skipping any numbers, think about what we would call that domain. Range, you start here and getting up. So think about what you'd call that. Y-intercept, where does it cross the y-axis when x is equal to 0? So you could just plug 0 for x in this equation and work it out and see what the y-intercept is going to be. Relative minimums, there is a relative and absolute minimum. So just kind of look at it and find out what that is. And then if it has any maximums, I'll tell you right now, there are no maximums because it goes up forever. So again, same information we've been talking about: domain, range, y-intercept, minimum, maximums.